Okay, this is a lesson on section 10.1, how to graph quadratic functions in the form ax squared plus c. The most basic graph you can look at is y equals x squared. So to begin, we're going to start by making an xy table. And let's plug in values of -2, -1, 0, 1, and 2. Let's be careful, when we square a negative, we should get a positive. So -2 times itself is a positive 4. -1 times itself is a positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So let's go ahead and plot these 5 ordered pairs and see what we get. What we're going to have is a U-shaped graph. If I go ahead and connect these points with a smooth curve, I get a U-shaped graph that opens up. And there are some key terms you're going to have to know. Every quadratic function has a U-shaped graph called a parabola. The highest or lowest point is called the vertex. The vertical line that goes through the vertex is called the axis of symmetry. As you can see on the diagram, you can either have a vertex at the highest point, or you can have a vertex at the lowest point. The axis of symmetry is the vertical line that goes through the vertex that cuts the graph in half. So this is the axis of symmetry. So what we're going to have to do is figure out what these numbers in front of the x squareds do to change the graph. And here it is. If a is positive, the graph opens up. If a is negative, the graph opens down. So by opening up, we're referring to a parabola that has a vertex at the bottom. And by opening down, we're talking about a parabola that has a vertex at the top. As the absolute value of a gets larger, the graph gets more narrow. As the absolute value of a gets smaller, the graph gets wider. Let's look at a couple examples to illustrate that. The first example would be y equals -x squared. Now with the negative a is going to be equal to -1. We can predict that the graph opens down. Let's go ahead and plug in a few values to see that. All right, so -2, let's see, the opposite of -2 squared. Order of operations will tell us to square the -2, so that's the opposite of 4. Let's see, the opposite of -1 squared is the opposite of 1. That'll be 0. And let's see, 1 squared, the opposite is -1. And so plotting these 4 points, let's see, -2, -4. -1, -1, 0, 0, and let's see, 2 squared, the opposite is -4. So what we have here is the mirror image. You might call this a reflection across the x-axis. Notice this is the same width because it has the same absolute value. The absolute value of -1 is 1. Let's look at the next example. If we're going to graph this 3x squared, you might recognize that a is equal to 3. So going back to what we wrote down, as a gets larger, the graph gets more narrow. So what you can predict here is that this is going to be a little bit more narrow than the original x squared. Well, let's plug in some values here. So this is 3 times -2 squared, which is, let's see, that's going to be 3 times 4, which is 12. 3 times -1 squared, that's going to be 3. And then 3 times 0 squared, that'll be 0. If you plug 1 in here, you're going to get 3. Let's plot those points. -1, 3 is on the parabola. -2, 12 is way off the graph. But we do note that 0, 0 is on, as well as 1, 3. So if I connect these with a smooth curve, you're going to recognize the parabola that's a little bit more narrow than the typical x squared. All right, so the third example looks like we have 1/2 x squared. So let's see, going back to our relationship, as a gets smaller, it's going to get wider. So let's see, a is equal to 1/2. So we're going to expect a little bit more width to the graph. It's going to be wider. All right, so let's stick to these three values. We can limit ourselves to those three. So that's going to be 1/2 times -1 squared is equal to 1/2. 0 squared times 1/2 is 0. And then 1 squared times 1/2 is the 1/2. So let's see, I'm going to put this in blue. -1 1/2 is here. 0 0 and 1 1/2 is a parabola that's going to be wider than normal. All right, another parameter change that we have to look at is this C value. As C gets larger, the graph shifts up vertically. As C gets smaller, the graph shifts down vertically. Another point of emphasis here is that this value of C is the y-intercept. And let's relate that to your prior knowledge base a little bit. If we have a linear function, we know that we can write it as y equals mx plus b. Notice here this last number was your y-intercept. That doesn't change. Your last number is your y-intercept with the quadratic functions. All right, so with these two examples, we're going to compare these to x squared. I would predict that this vertically shifts down 3 because c is equal to -3. And let's verify that with our table of values. Once again, we're going to just limit ourselves to these values, -1 0 1. So let's see, that's going to be -1 squared minus 3, which is 1 minus 3, which is -2. Let's see, 0 squared minus 3 is -3, and then 1 squared minus 3 is -2. Let's see, so -1, -2, 0, -3, and then 1, -2. And so what we have here is a parabola that has the same width because it has the same a value. The a value is 1, the a value is 1, but we're going to have it shifted downward 3 units. Looking at the next example, we see x squared plus 2. X squared plus 2 is going to be another vertical shift, but it's going to go up this time. And we can verify that through our ordered pairs. Let's see, -1 squared plus 2 is 1 plus 2, which is 3. 0 squared plus 2 is equal to 2. And then 1 squared plus 2 is equal to 3. If I plot these three ordered pairs, I'll get -1 3, 0 2, 1 3. And I have a parabola opening upward with the same width as x squared, but it's shifted up 2 units. All right, so the challenge here is putting these concepts together. So we talked about looking at our a and c values. A is equal to 2, c is equal to -4. And it should tell us things about this graph to help us put it together. With an a value of 2, this is going to be more narrow than normal. It's also going to open up. So this goes back to the beginning. As a gets larger, the graph gets more narrow. And if a is positive, the graph opens up. So those two things are going to help us recognize that picture before you even graph it. This c value means we're going to shift it down 4 units. All right? So now to help us picture how more narrow this is, we still need to do some values. Let's plug 1 in first. That's easier. That's the easiest. Let's see, 2 times 1 squared minus 4 is 2 minus 4, which is -2. Let's see, 2 times 0 squared minus 4 is -4. And by now we should have seen that -1 will have the same value as 1, so that's -2. So plotting these ordered pairs, 1 -2, 0 -4, and then -1 -2 gives me this parabola. You may note that it is more narrow than normal, so that's exactly what we predicted. And we will note that it opens up, and notice that we have a parabola shifted down 4 units. Here's another good example. Notice our a value is -1/2. So things we can say about this graph is that it'll open down because of a -a, and this is going to be a little bit wider than normal. To figure out how much more wide, you have to go ahead and find some ordered pairs. I'm going to make a table of values. Let's see, so -1 0 1 for x. I'm going to move this over here, down here. Here we go. So x and y, see negative 1, 0, and 1. Let's see, plugging 1 in, this is negative 1/2 times 1 squared. Squaring the 1 is 1. 1 times negative 1/2 is negative 1/2. Let's see, negative 1/2 times 0 squared is just 0. And negative 1/2 will go to the same value as 1. All right, so plotting these three ordered pairs, I get negative 1, negative 1/2, 0, 0, 1, negative 1/2. And we have a parabola that's going to be a little bit wider than x squared. It opens, it's wider, it opens down, and there is no c value, so there is no shifting vertically up or down. So we do have a vertex here at 0, 0. All right, another example here. We have an a value of negative 1. We have a c value of 1. So what that tells me is this will have normal width. Anytime you have an a value of 1 or negative 1, we consider that normal. It's not wide or narrow. This will open down because of the negative value, and the c is going to shift it down. So I'm going to use these parameter changes to sketch a graph. I know that this shifts down 1, so the vertex will be at, excuse me, I messed up. The c value equals to positive 1, so it's going to shift up 1, and so your vertex will be at 0, 1. This thing will open down because of the negative a, and you're going to have normal width, so something like this. This is a close enough graph to the actual curve.